Hello friends, welcome to Edupedia Word videos. Let us study usage of Pythagoras Theorem and its converse. Friends, Pythagoras Theorem says that in a right triangle, hypotenuse square is equal to base square plus perpendicular square. Whereas its converse says that if we have hypotenuse square is equal to base square plus perpendicular square, then it is a right triangle. Now we will be having three questions. First, to check whether a given triangle is a right triangle or not, and the other two will be to prove based questions. So the first question says, check if the triplet forms a right triangle or not. Friends, for checking the right triangle, we need square of all these sides by using the converse theorem. So 13 square will be 13 into 13, that is 169. 12 square is 12 into 12, which is 144. And 5 square is 5 into 5, which is 25. So clearly the shorter squares are these. So we will add up these two squares to check whether they are equal to the bigger one. On solving, we will get 169. So yes, they are. Their sum is equal to the square of the bigger one. Hence this side is hypotenuse and one of these side is perpendicular or base and the other base or perpendicular, and hence the given triplet forms a right triangle. Let us have a second question. The question says D and E are points on the sides CA and CB of triangle ABC right angled at C. So we have a triangle ABC which is right angled at C, so vertex will be C, and D and E are 2 points on CA and CB. So on CA we have a point D and on CB we have a point E respectively. We need to prove that AE square plus BD square is equal to AB square plus DE square. We have AB as this side, but what is DE? We need to join D and E to form DE. So join DE. Similarly AE, which will be formed on joining A and E, and similarly for BD. So now we have formed certain set of right angle triangles DEC, AEC, BDC and ABC. So first of all, the complete triangle, the right triangle ABC. Here we have the hypotenuse as AB, so AB square is equal to AC square plus BC square. Now the second right triangle is BDC. So we have in right triangle BDC, BD square is equal to DC square plus BC square. Similarly, another triangle is AEC, which is right triangle. So we have hypotenuse square is equal to AC square plus EC square. The last triangle is DEC. So we have in right triangle DEC, DE square is equal to DC square plus EC square, where DE is hypotenuse and DC and EC are base and perpendiculars. Let us name these equations as 1, 2, 3 and 4 respectively. Now let us pick up the left hand side of the to prove part. The left hand side says AE square plus BD square. From equation having AE and BD, that is second and third, we can say that AC square plus EC square plus DC square plus BC square is the simplified left hand side from second and third. Now in the right hand side we need AB, and from first AB is AC square plus BC square. So we are already having AB square in left hand side, but we need to rearrange the terms to use first equation. For we also need DE, which is DE square is DC square plus EC square. We are having this over here, but we need again rearrangement. So on rearranging, we have AC square plus BC square plus EC square plus DC square. Now from first and fourth, we can say that they are equal to AB square and DE square. So this is, my dear friend, the right hand side, and hence the given question has been proved. Let us have a last question. The question says, in an equilateral triangle ABC, D is a point on BC such that BD is equal to 1 by 3 BC. So we need an equilateral triangle ABC, and we have a point D. Since BD is 1 by 3 BC, therefore BD will be the smaller divided part of BC, because the other part will be 2 by 3 BC. Now we need to prove AD square is equal to AB square with some multiples. So we need AD. So we need to join A with D. So in the solution part, since ABC is an equilateral triangle, therefore AB is equal to BC is equal to AC. Let this be A units. Let this be denoted by a constant parameter A. So BD is given as 1 by 3 BC. So we can say that it is 1 by 3A because we have denoted BC by A, and similarly for AB and AC. Friends, we don't have any formula in this chapter for equilateral triangle with their side squares. So we need to introduce a right triangle to have some squares of the sides. So draw a perpendicular from A on BC. This be AP. In construction, we have drawn AP perpendicular to BC. Friends, for an equilateral triangle, if a perpendicular is drawn, it bisects the side on which it is drawn. So here BP will be equal to PC and will be equal to half of BC, and BC is A units, so they will be equal to half of A units. Now why we have constructed right triangle? To introduce square terms by Pythagoras theorem. So let us apply Pythagoras theorem first of all on this ADP, because we need AD, which is the hypotenuse of ADP. So in right triangle ADP, we have hypotenuse square is equal to base square plus perpendicular square. Now what is DP? DP is BP minus BD, the complete half side BP minus this part given BD. Now BP is from here 1 by 2 units, 1 by 2 A units, and BD is 1 by 3 A units. So we can take LCM and we will have 1 by 6 A units as DP. So on putting this 1 by 6 units here, we can say that we have AD square as this, but we need AB square in our right hand side. So to introduce AB square, let us have a right triangle having AB as one of its sides, which is this right triangle. So now right triangle ABP, hypotenuse square is AB square, which is equal to BP square plus AP square. So from here we can say that AP square is AB square minus BP square. This forms the our two purpose. First we can substitute AP square with some other term, and that other term will introduce AB square in the left hand side, which is the given portion of the right hand side. So put 3 into, so we will have AD square as 1 by 6 A square plus AB square minus BP square. Now what is AB? AB is A units. So here we can write it as A square, and for BP is 1 by 2A, so we can write 1 by 2 A square for BP square. So all in all, we have got the whole result as 1 by 6 A square plus A square minus 1 by 2. Here it is the whole square of 1 by 6 and A, so 1 by 2A whole square. So on solving the square, we have 1 by 36 A square plus A square minus 1 by 4 A square. Now on taking the LCM of this, we can say that AD square has become 36 as LCM, and A square can be taken common from all the terms. So we have 1 plus 36 minus 9, which on simplification will give us 28 over 36 A square, and on further simplification will give us 7 by 9 A square. So we have achieved AD square as 7 by 9 A square, but we need AD square as some term of AB square. So we can substitute from this equation A as AB. So finally we have 9 AD square is equal to 7 into, in place of A square we can write AB square, which is the required to prove part. Hence the given equation in the to prove part has been proved. So friends, these were some questions on Pythagoras theorem, its usage and its converse usage. Thanks friends for watching this video.